Already recording.
Yeah, this is
It's
how I hopped
early.
in.
Oh, did you set it to like auto record or something?
Yep.
Oh, cool.
I can tell it to
Hmm.
pause though. Recording before I start sharing. Because reasons.
Yeah.
So does that look good to everybody?
Yeah.
Cool.
Yep. Good to me. Okay. So, looks like we have everyone here. Or not everyone, but everyone who is going to show up to kick off tonight. So that's good. I want to thank all of you for coming, and I want to start by just saying, welcome to a new semester. We do intend to make this a new semester, hopefully do things differently a little bit than last semester, do more things than we were able to do last semester. For those who don't know me, my name is Cameron, and I'm the president of ArrowNU. And that means that I just kind of work behind the scenes to keep the club running, but it also means I'm a good point of contact if you have questions about how the club is run, how you can get involved, all of the above, right? I joked earlier that I have been rightfully criticized for being a perpetual optimist, where I always am like, oh, we can get this done, we can do more, we can do all this. And it's like, yes, but I have to report that I'm once again encouraged and enthusiastic about this upcoming semester. I mean, I've seen the projects, I know the people, and I know that there's a lot of potential for this semester, and I'm excited for new and returning members for what we're going to be able to do. So, if this is your first ever Arrow NU meeting, I want to be the first to say, welcome to the club. You may have heard us say before that like experience is not at all required to be a member of the club. Passion, it really is true that passion and curiosity about these things and getting involved will take you so much further than just experience. Um, and I also know that many of you might have come because you heard about a specific project that you were interested in working on. That's great, and I hope that you get involved and work on that project. But I also hope that you stay because of the people that you get to work alongside. Right, something that we're really trying to do this semester is build a community that can last. Right, build something that's going to succeed for semesters or years to come. Not just the projects, but the overall club. So I want to also encourage you to just reach out to every single project that you hear about today that you're even remotely interested in, because getting involved in one of these, I mean, it's what I did many semesters ago, and it's why I'm still involved now, right? Just because I ended up reaching out to someone that I might not have reached out to otherwise. So please, please, please reach out to people. They're really great to talk to, and they would love to hear from you. To everyone else, last semester was difficult because we kind of battled against everything, right? Being remote, that brings its challenges. Being, we have a rocket now literally titled "Travel Request Denied" because we weren't able to go travel and launch it. That's totally understandable. We're going to work with the regulations that we have, but myself and the rest of the e-board are totally committed to doing more, like really, really pushing what we're allowed to and able to do, while obviously still being safe. So just some very quick highlights. We have completely new rockets with custom electronics, custom software. We of course have brand new experimental airframes coming out of NUAV and fixed wing. And you can also join racing. We have so many like opportunities this semester, and I really want all of you to take advantage of it. And if there's any way you see that we can expand our opportunities, that we can do more, let us know, because we really, really want to make this semester successful. So with that, I don't want to ramble too long. I want to just pass it off to our projects. They are the ones who actually do everything. They're the ones responsible for all these experiences. So I believe our first one is intro, and I will pass it off to Shayla to just take it away.
Hi, so thank you. So hi, my name is Shayla. I am the project lead for Intro to Rocketry. We're about to enter our first ever spring semester as a project. So I'm going to run through some of the things we accomplished in the fall and what we're looking forward to in the spring. Nice. So we're divided into 4 tracks. They are namely airframe, avionics, mechatronics, and propulsion. So the first track, avionics, accomplished quite a bit in the fall. You can see on our slide here that a lot of rocket theory was gone through, and actually some SolidWorks modeling as well. each member built a kit rocket. It was launched and recovered over on the Dedham campus, and designs were begun for some more high power rockets. You can see an example at the bottom of this slide and also to the side. And here are some photos and videos from our launch in Dedham this past November. It's a great time, pretty field, a little small, but overall a very successful event. And hopefully we'll get to do more of this in the future. I have to say, you're missing the best part, the audio. You'll have to go find them. They're in the drive.
Oop. Sorry. Next slide. There we go.
Yeah, thanks. So for the spring, Airframe is hoping to actually start modeling and building e-bays for the high power rockets. They're going to complete those designs and they're going to build them. And these particular rockets are going to be able to interface with 2 other tracks in the intro course, and that's avionics, where the boards are going to be incorporated into the e-bays, and mechatronics, where their payloads are going to be able to be integrated into the airframe rockets. And so at the end of our timeline here, we're going to launch. And I cannot wait for that to happen. It's going to be fantastic. So with that said, moving on to avionics. In the fall, a club designed Arduino. Everyone built one. It was awesome. A lot of hands-on skills, a lot of soldering that was built up, and a good background in board design. So this built up a lot of the electronics and programming concepts as well, which is great for our plans this spring on the next slide here. So now what's going to happen in avionics is they're going to develop some new flight control boards for the club. So the club usually has used Stratologgers, which have then been replaced by Easy Minis, which, as you can see, are more expensive. So as a great, introduction, a great critical part of development for the club, avionics is going to work on developing a custom board. We're going to test them, we're going to build them, and we're going to hopefully get to fly them on an NUAV drone and collaborate with the airframe track. So in mechatronics, in the fall, they also went through a large SolidWorks 3D modeling course. They developed 5 total payload designs for a projectile competition, where after ejection from the rocket, upon landing, they'll have to put a projectile a precise distance. So at the end of last semester, PDR was actually presented on all 5 of these, and these are the ones that are moving forward into the spring. So after PDR, we're going to continue to develop those designs, then conduct a CDR, critical design review, and build all 5 of those payloads, integrate them with the rockets, and test them, and then hopefully we'll get to launch those as well. And so finally, prop propulsion, our 4th track, a lot of thermodynamics and fluid systems principles were covered in the fall. So taking that, they actually went and designed a small uncooled rocket engine, which was then modeled in SolidWorks and also simulated and had the NASA CEA tool running behind it. And so with all of those designs from all the groups, they're going to choose 1 to 2 of them to actually machine and test in the spring, which on our next slide here, that's going to involve a couple different steps. So the engine flow and the cooling still need to be designed. The test stand still needs to be kind of ramped up. It needs new electronics. It's going to be computer integrated. It's going to be able to measure force. It's going to be awesome. So we're going to manufacture that, manufacture the engines, and then perform a cold flow and a hot fire. So it'll be very eventful, very fun. Hopefully we'll get some good images out of it. So if you guys are interested, these are our meeting times this semester. Please reach out to one of these points of contact directly, because we've been through a whole semester of work, so you got some catching up to do, but if you're really interested, we'll be there for you. So feel free to add us in the Discord. Thanks.
Oh,
Are we good to go?
I think we're good to go. Hi, I'm John Dusick, and this is Noah Osana, and we're the 2 principal leads for NUAV.
Cool. So what do? We are Aero and U's entire subset of drone projects, and then drones as in multi-rotors. So what our current goal is we're unified in the pursuit of a project called Storm Carrier, and what that is we're going to drop and reintegrate multiple smaller drones from a really, really big single one. We've been working on this for several years. A lot of projects have culminated into it, And so now's a really exciting time to join because the whole system's really coming together. So just like the big subtasks that are a lot of CAD, a lot of prototyping, a lot of manufacturing, we have to make a lot of things. A lot of our assemblies are huge and have a lot of components. There's a lot of integration of sensors, and there's a lot of simulations of the systems that we're trying to achieve. And then we're also doing a lot of education and teaching members how to fly these drones because that's where we all started.
All right, so what did we do last fall? Even though we were remote, we accomplished a lot. We built and tested our entire fleet of the swarm drones that we showed in the last slide. We tested a parachute deployment for DPF.
That was a super fun
That was
test.
a really fun test.
That's like one of the tests. Some of the coolest tests in this club are the interdisciplinary tests between projects, and seeing that payload deploy and also our drone being able to fly that high. And that was a test that's open to all members, of course. So any project you're in, you'll get to see things like this. But this is one of my favorite things about this club personally, is we had a lot of people there seeing that. And even though it was socially distant and we couldn't all be, together really enjoying the moment, everyone still got to see it. So, but I just wanted to say that.
In the top right corner, you can see it too. All right.
That was a fun day.
Yeah, our software team completed our advanced decision-making autonomy, which we call behavior trees, which was really cool because it means that our drones think a lot faster and have more organized minds. We also collected a lot of stereo camera, just images of drones flying over what we call RUCO markers that will assist us in precise drone landings that we're going to need to land back on our large airframe. Then we evaluated many multi-drop mechanisms, which some worked better than others. And
yeah, it's been a field of research in our club to determine how to develop these mechatronic payloads to drop and reintegrate drones. More recently, reintegration became a design criteria for that. And I'm really excited about how far we've come, but there's still a lot of work to do, and that's why we need everyone's help to do so. But like I said, the system's coming together, so it's a really exciting time to see that. So the last thing, in addition to the fact that we also designed a prototype for the UHL, which we'll get into later, is there's drone racing. We've had a lot of high finishes, even though it's been remote. There's been a lot of simulator tournaments in drone racing, so we've placed very highly in the Collegiate Drone Racing Association, a new international drone racing league that we've become a part of, and also first place at Multi-GP STEM Alliance race, which we'll get into later. Really cool stuff. Okay, yeah, so NUAV is divided into two groups, hardware and software at a very high level. What hardware is concerned with is things like airframe design, payload design, how we're integrating the actuators into those mechatronic payloads that we were talking about, how we're messing around with all of our electronics. So we deal with also, much like Intro to Rockets mentioned, we deal with a lot of custom electronics ourselves because a lot of off-the-shelf components really won't work. And then there's also a lot of sensor integration and analysis. That's like a really high level. We'll get into it more in the meetings, but just to explain some of the pictures you guys are seeing here. On the upper right, this is a video test from last weekend, actually, of a drone frame that we call wood because it's entirely made out of wood, the best prototyping material in existence, not because it's the cheapest. No. So what this is it's a 1/3 scale replica of the dodeca that you see in the bottom right. That's a SolidWorks render of the assembly. It's a 1/3 size model of that vehicle. We've never made a dodecacopter, so that's 12 brushless motors mounted in a coaxial configuration for a compact form factor, but with great thrust. And what's novel about this airframe that we're trying to design is it's actually hollow because it has to have drones be able to land on it, pass through it, and come out of the bottom. So you can see the design for those mechatronic bays that we were talking about, those two square things on the bottom there. Those are in production right now. And so the ultimate vehicle will carry 2 of those and be able to deploy and reintegrate up to 6 drones. And those are the swarm drones that we already created last fall. So anyone who works in hardware will get the opportunity to work on those firsthand and also develop these mechanisms that we're dealing with.
Yeah, and alternatively, this could be used to carry small children. All right.
Any enthusiastic pilots, we're open.
Yes.
Okay, anyways, software. This is the second group, John. Do you want to?
So the second group is devised, is our software group. And it uses, so like I've said, we've had a lot of advancements in hardware, but it has come with similarly large advancements in the software. So our software team works primarily in Python, but we've been doing more and more in C++. Our software team teaches ROS, which is a robot operating software, which is how our drones basically talk to themselves, but also talk to each other. So when we go to more swarm drone applications, people that are working on that will have a chance to work, Tyler and Ross. We've also developed many simulations. You can see in the bottom right our gazebo simulation, which has our CAD model for our swarm drone as well, which is really cool. And it's performing a precise landing with an Aruka marker shown below. Yeah. So there's a lot of exciting things to be done in software, and hopefully we'll see many of you there. Is Pedro online?
Pedro, Ryan, you want to take this slide?
Hello? Can you hear me?
Yeah, we can hear you, Pedro.
Awesome. So, Quad Camp. So in addition to all these fantastic research projects, NUAV also loves to fly drones really, really fast and crash really, really hard. So basically, we take these small 5-inch drones and we control them with a good old RC controller under some FPV goggles so that you're basically inside of the drone controlling it. And we just go fast, we crash hard, and we have fun. And so the best part of this, anyone can join for free. We'll have multiple drones ready to fly. We have so much gear. We just need people to come and fly with us. So we're hoping to meet weekly or every week on Saturdays in a park and fly together. We can teach you how to fly, how to build, and we just want to have fun with everyone.
Yeah, so a quick recap of everything. Want to get for anyone wanting to get involved, software, very exciting place to get involved right now. So John mentioned languages like ROS. Anyone who's trying to get into robotics professionally right now, ROS is the language to learn. It is what is used in development. It's a very ubiquitous language in the industry right now. And all of our software is, well, the combination of it is entirely custom. So we have a lot of awesome tutorial videos that we constructed in the fall. The leads are very accommodating to get people on board. And it is a very advanced system. And it does have a learning curve. But the point of NUAV and Aerospace NU is to have, there's no entry barrier. We will teach you. It's very exciting. The skills that can be learned are very useful. With that, also hardware, similar front. There's a lot of complex assemblies that we work with. There's a lot of complex systems that we work with. But it's very collaborative. We have a whole repository in GrabCAD, just like a lot of the other projects in this club. So we do a lot of our design and software. So there's a lot of advanced modeling techniques that we really like to pass off to members, and we like to learn from them too. It's really good to kind of blend everyone's styles of work together, because then you learn as a group. And then also there's a lot of work to be done with sensors and actuators and to drive all the payloads that we're talking about. So we're really excited to work together to accomplish those goals. And then lastly, Quad Camp, as Peter just mentioned, we're going to have very regular sessions that you can learn in the simulator, you can learn outside of the simulator. It's a very immersive experience, tactile and sensory. So it's really fun to learn, and there's just so many skills. It's very interdisciplinary, as robotics generally is.
All right, and then here are our meeting times. We meet many and often. One of the main points that we try to do at NUAV is we have many meetings throughout the week so that our members, if they're doing something else at one time, they can come to one versus the other, or both if you have the time. But we will update you as you can. Yeah.
And racing times, at the time we made this presentation, we hadn't really solidified that yet. So just be on the lookout for that. We'll probably try to get some message out through the e-board to talk about that, because we don't really have an official time set for that. It's kind of pending on approvals given COVID and everything. But feel free to reach out to us. Our names are there. Message us on Discord. If you don't know how to use Discord, just hop in the intro thing. There's a lot of leads are there to assist. But yeah, Discord is our go-to. That's where all of our meetings are. We have meetings multiple times a week in the voice chat. So we hope to see you guys there. There's a lot of fun stuff to work on. Not only our project.
Alrighty, my turn. Hello, everyone. My name is Isaac, and I am the lead of Project Redshift for this semester. So Redshift is basically our giant rocket project. We've had previously several rocket projects running simultaneously. in addition to intro. And this year, Redshift has encompassed all of those that are not intro into one massive project. So what Redshift is, basically our goal is to build huge rockets. And the goal of this particular project, after we build a couple large rockets, is to build the biggest one we have ever built and fly it on a liquid fueled engine, which is something we have never done before. So all of the rockets that you might see in pictures, like the one right here on the right, are solid fueled rockets. We buy those motors like commercially off the shelf. We don't make them or anything. But the end goal of Project Redshift is to build a completely custom liquid bipropellant rocket and fly it ourselves. So we've done a tremendous amount of work on that so far. We started this project back in May of 2020. So still relatively new actually compared to some of the other projects that have been happening for a long time in this club. But we've made some pretty interesting progress here. The reason we're doing this project actually is there's a kind of a hobby rocketry group out west in California called the Friends of Amateur Rocketry. And they're hosting a competition called the $1 per foot competition, where if we launch a liquid fueled rocket, they'll give us $1 for every foot that our rocket goes up. And the reason you're asking, like, oh, why would they do that? Like, they'll lose so much money. The reason they're doing that is because it's really, really, really hard to build liquid fueled rockets, like really hard. That's part of the reason we've never done it before. It's also can be pretty dangerous at times. So there's a lot to do to get there. We've made some good progress, but we have a lot of new vehicle design to do and mechanical systems to build to handle our parachutes and handle all of the liquid propellant systems that we've never done before, and a lot of electronics and software to control all of those systems as well. So a little bit of detail about the breakdown. Actually, I guess I missed a slide. Project progress. So what we've done in the past 8 months, I guess, we built the first of 3 intended rockets. And as Karen mentioned before, that first rocket is called Travel Request Denied because we have attempted and asked to launch it several times and our requests were denied every time. So Travel Request Denied is the first of 3 rockets. It's going to be much smaller, or it is much smaller than what our final rocket will be. It's about 5.5 inches in diameter and it'll be about 8 feet tall or so. That rocket's just about completed and we're hoping to launch it this semester. We've made progress on a new parachute release and control mechanisms, including parachute reefing and controlling that with both mechanically and with nichrome cutting wires as well. We've designed new avionics boards to log data, to control flights, to handle like ground station radio reception, and to cut wires with nichrome as well. We've actually just started our engine manufacturing process over winter break, and actually that picture in the middle on the bottom, that gray funky looking thing, is the bottom half of our engine, and that's 3D printed out of Inconel. So it's pretty cool, and we're going to actually send that to a company to sinter and solidify into what the final metal engine will be. We've also been lucky enough to have a group of capstone mechanical engineers who designed the entire propellant feed system for this engine. And so they've made a lot of progress on that, and it's our responsibility to continue that progress after they did that last semester, and we're going to continue it this semester. And also we've been doing a lot of fluid flow simulations and flight profile simulations as well to try and model what the different geometries thinking about designing the final rocket will be and how they will impact our flight profile and how high we'll go. So how you can get involved, we have 5 different subgroups of Redshift currently, and those are listed here: airframe, internal mechanics, avionics, propulsion, and simulations. So airframe is doing pretty much all of the exterior geometry of the rocket, as well as any like structural members on the inside that handle the thrust of the engine. So that includes any body tubes that make up the outside of the rocket, the nose cone, the fins, incredibly important, and we're doing some interesting work there to try to make our fins as lightweight as possible with different carbon fibers. So they're pretty heavily involved in the aerodynamics of this rocket, as well as a lot of the internals as well, because we have to find ways to handle the giant thrust loads that this engine is going to produce and prevent any of the tubes or internal components that we have from breaking during flight. Internal mechanics handles exactly what the name says, all of the internal mechanical systems of the vehicle. So that includes our parachute control systems, potentially an up-and-coming Marmon clamp system to basically clamp different size tubes together, as we're thinking about a large tube on the bottom for a propellant section and then a smaller tube on the top of our rocket for all of the other stuff that doesn't need the extra space that the propellant section needs. Our avionics team has, as I said earlier, designed a wide variety of control and data logging boards already. We've started assembling those boards this semester, and a number of people have started writing software for those boards, and we're hoping to test them actually in flights this semester, which should be pretty interesting. They've also started a pretty serious data logging and data filtering project recently, with the goal of basically filtering out noise and disturbances from the flight data that we collect from all of those boards to get as precise as possible data that we can use for simulation verification later on. Our propulsion team, a big part of what they've been doing recently is the engine manufacturing. So you saw a picture there of the first half of the engine printed. The second half is actually printing right now in the printer in the Forsyth building. Once we get that second half done, it's about an 8-day print. We're going to send both pieces out to be commercially sintered, as I said earlier. They're also doing a lot of work on the test stand because we need to like cold flow and hot fire these engines first before we put them on our rocket. So we have a test stand to handle that. And so we've been doing a lot of refurb and upgrades to accommodate this engine. And hopefully by the end of this semester, we'll actually conduct a hot fire up in Maine at a company that's been generous enough to allow us to hot fire there. And the last but not least, our simulations group, as I said earlier, they do a lot of flight profile and fluid flow sims. So we pass them off different fin geometry, nose cone geometry, body tube shapes, and they run fluid flow sims and determine how those different shapes will affect how high we'll go and what the stability of our rocket will be, predicted flight data, all of that. There's literally a tremendous of opportunities across pretty much any discipline you could think of related to engineering and science. So I really encourage you to get involved. Certainly some may have a higher barrier to entry than others, but we are encouraging anyone of any skill level to please get involved because we need help with this project. And we all started with little to no experience and came from nothing, and now I'm leading this project, which is kind of weird. Didn't expect to be, but that's how we all start. We have no idea what's going on, and then we figure it out by just going with the flow. So you can see all of our meeting times listed here. We meet a lot between all of our subgroups. Each subgroup is going to have one meeting a week virtually. We also do have some general project lab time twice a week for 2 hours each. I will be posting in the DPF Discord channel, the general one, basically who is going to be meeting in the lab each week, so we don't accidentally overfill the lab. I believe right now it's rated to 7 people and 1 TA. So we want to make sure we're not putting too many people in there. And then every other week, we also have a bi-weekly meeting. I just said that twice. We have a full project meeting, excuse me. And that's just an opportunity for our entire project to catch up with each other. We're pretty big already. We're about 30 people between all 5 subgroups, might be a little over that at this point. And so we use that brief meeting every other week just to make sure we're all still on the same page regarding the progress we're making and the tasks at hand. So definitely email me or preferably DM me on Discord if you have specific questions about a subgroup or a specific project that we're working on. We are always looking for more people. We have a tremendous number of projects and systems to finish up in the near term, if we're even gonna have any hope of flying our final rocket within the next year or two. So please, I do encourage you to reach out and join. And that is all I have. Thank you very much.
So my name is Ben, fellow project lead is Matthew, and we are the fixed wing project. As the fixed wing name would suggest, we do planes. UAVs got the vertical propellers, we have the horizontal ones. Although that is a topic of our current project we're trying to run this year. But what we're trying to do, or what we hope you guys can get from us, is some basic flight concepts, practice with SolidWorks and GrabCAD. If you want, we're always open to new ideas, which means if you want to bring some electrical engineering into the mix or some programming, we're always welcome to expand what we're doing. Yeah. So for the first 2 weeks or so this year, we are going to finish up our build from last semester, which is just a pretty straightforward plane. And that just didn't get finished because of the disaster last year was. But looking sort of for the rest of the semester, we're hoping to do some VTOL, like a vertical takeoff and landing plane. And that is definitely not something we could finish this semester. So we're hoping to turn it into a longer term project, one that we can test out a bunch of different ideas and experiment and just sort of see what works. And then similar to NUAV, we're trying to run some learn to fly days as well. We have 2 sort of off the shelf foam planes that are really fun to learn to fly on, to just fly around and see how many loop-de-loops you can get before you accidentally hit the ground. And hopefully, sooner rather than later, we'll have a plane we've built to fly.
Hey guys, so just reiterating what Ben said, our first couple weeks, two, 3, maybe a month, we have to be working on finishing up our plane from last semester, specifically landing gear redesign and wing redesign. Heading off of that, we are looking to start our research and our new section for the VTOL project that we're super excited about. As Ben mentioned, not really going to be building, just getting research, getting designs going, maybe getting some testing in the lab. And then as you see on the time schedule there, about once a month, whatever works for you guys, whatever we want to do for flying planes. Our meeting times and contact info, obviously you see our emails there. DM us on Discord. There's an interest form which I'll post in the chat after I'm done talking. I'm sure Cam might have a general interest form for all of aerospace, so be on the lookout for that too. Our meeting times are 6 to 8 p.m. on Wednesdays. These are our virtual meeting times where we get together as a team, go over research and design, go over SolidWorks and GrabCAD skills, and also prep for lab times on Tuesday. Tuesday, our lab times are currently 7 to 9 in the beginning of the semester. We might get shifted back towards starting around 8 o'clock later in the semester, so just look out for emails and Discord message about that. In the lab is where we work on our 3D printing, our laser cutting, which is a lot of that we're doing this week, electronics, avionics, and assembling our general plane. We're a smaller club. We have about 5 guys and then 2 more who are currently remote from campus. So if you're really looking to get involved right away, get your input in, get hands-on, then we'll look up for you. So hopefully we see you guys in some meetings.
Great. I was actually going to hop in for just 1 second before we talk about spring events, because you may have heard a couple of different projects talk about lab time and what that is. And so we don't actually have a slide on it this semester, but one of the kind of hallmarks of our club is the lab that we have in 244 Forsyth, right? It is graciously provided to us by Professor Bridget Smizer and Professor Andrew Goldstone, our advisor. And we have all kinds of manufacturing capabilities as well as just workspace capabilities. And for the majority of last semester, we weren't able to do any work in there because we, for obvious reasons, they hadn't approved any work, even though they had approved in-person classroom space with reduced capacity. They hadn't approved student groups working in lab space. We worked with the university, we pushed real hard, and by the end of the semester, they actually agreed to it. And so we're looking to hit the ground running this semester. We have about 16 hours of approved lab space time in 244H Forsyth, and that'll all be handled by the projects. Oh yeah, the lab page is on the website. I don't know if someone wants to link it in the chat, but it's really cool. You can see all the different things we have in there: 3D printers, CNC, laser cutter, water jet, general electronic stuff, a whole closet where we put all of our gear. And really, the lab in normal semesters is the basis of our community, right? It's how you interact with how members interact across projects. You see people in there, you talk to them, you hear what they're interested in, you get homework help. That's all somewhat faded a little bit. So as we have limited capacity and limited operating hours in the lab, we hope to kind of bring that back. But kind of transitioning, we also are going to try to run some events to help rebuild that community this semester.
Hi,
So
I'm
yes.
back again. Are you gonna do it? Go for it, Nolan.
Yeah, sure, I'll do it. So hello, I'm the outreach coordinator. My name's Nolan Brown. We didn't do an e-word introduction, but so my job, as Cam was mentioning, and as Cam mentioned at the top, is to do more things with you guys. Obviously with COVID and stuff, it's all kind of gone to hell, but lots of virtual events for this semester, and we want to get a lot where we want to replace in the fall. Normally, like Cam was saying, in the lab, people meet each other. Freshmen meet freshmen meet upperclassmen and leads, and they get involved and things like that. That doesn't really happen because we have no lab. So some of these events for this semester are going to be more social, and try to do the best job we can being social on online. So again, you can read the slide, but all those things, none of those things are planned explicitly right now, but they're just ideas we've had. If you have more, feel free to email us, PM me, let me know. Side note, we are looking for an events coordinator as well, because our lovely events coordinator, Shayla, is unfortunately getting old and will be moving on from us at some point. So if you guys want to get involved with the e-board, if you guys want to be social, if you want to meet more people, if you want to, I don't know, become outreach coordinator when I'm old and gone and stuff like that, stepping stone, feel free. It's something that I need help with, especially because I'm in Arizona, and Arizona is not anywhere close to Boston right now. So, well, it never is, but I'm in Arizona right now. So we can go to the next slide, I suppose. And then Spades is our Space Ladies group. They're in part of the Discord. They do their own events. They get coffee. Again, you can read that. But Shayla, you've already heard from her. The intro lead, we called her the intro god, is running it. If you have questions, let her know. But this is something we really wanted to promote because we want our club to be a place where everyone's welcome. Everyone has a space to be themselves, whether that's a gender-based organization within the club or race, ethnicity, or whatever. We just want people to feel like they have a home here, and we want to be very outgoing with that. So that being said, if anybody wants to start a group similar to Spades, just let us know. We are very nice. Again, DM me, PM me, I suppose is the other term. Email any of the club email, talking to the e-board members, whatever you want. But this is very open. And again, we want to be inclusive to everybody. So it exists, and please use it. And then our first event, hopefully we'll be doing more of these. Last semester, we did a couple employer events. We had Tesla in, things like that. So lots of, again, virtual stuff. But NASA having their rover, they're doing a lot of cool things. We're all going to be chilling together and watching it. Keep an eye out in the Discord. If you're not in the Discord, or if you haven't introduced yourself yet, haven't changed your name, then you're not going to get the notifications, and you won't be able to come. Well, I guess you could still come, but you won't be able to hang out with us. So this is going to be our first event. If there are employer events, we partner with, yes, Shayla is correct. It'll go out in an email as well. Employer events, events with other clubs, things like, we also do those sorts of things. So yes, and also at some point we're supposed to be having social media again, now that we're doing a bunch of things. So if anyone wants to be a social media coordinator as well, I will take this time to do a shameless plug and say, similar to the events coordinator, it's pretty low commitment, it's pretty fun, you'll be saving me some time, and we'll love you forever because we're a bunch of engineers who don't like being social. So there's my elevator pitch.
All right. Well, on that note, I will reject Nolan's idea that we are unsocial. I think that we are perfectly social. I guess I wanted to offer the floor to Ryan to say, how do we want to kind of let people find the projects that they're interested in, as well as any kind of closing remarks.
Yeah. So, hi everybody. My name's Ryan. I'm the current VP of the club, and I think Cam did a great job of explaining how things are coming on this semester. We're both very optimistic about how things are going to turn out. So, getting you connected with anything you're interested in, we've given you a wealth of knowledge of just what's going on this past semester. I will be posting this a link to this slideshow in the chat of this call, and then I'm also going to put it in the news and announcements channel in Discord for you to reference after. And sorry, somebody's knocking on my door. Yeah, so if you want to get involved, there's currently a channel in Discord that's called the Kickoff Connections channel. That's for you to just pitch, hey, I'm interested in this stuff in general, and somebody will connect with you and figure out where your best fit is. So let's say maybe you don't know specifically what kind of project you're interested in. You could just talk a bit about your major, your past experience, or what you're interested in, and we'll try to connect you with whatever seems best fitting. Yeah. We're really looking for suggestions for this coming semester for things to do outside of the projects like we talked about earlier with the social events, etc. So if you have anything fun that you just like to do and could involve other people, let us know. And we're totally down for figuring that out.
Also, I see that we have a celebrity in our midst. AG, did you? I saw you joined in. Did you want to say anything?
Yeah, I always love saying stuff. Hey, thank you so much for reminding me about the meeting and for having this. I don't want to say too much, but for those of you who don't know me, my name is Andrew Goulstone. I'm a professor in mechanical engineering, and I'm proudly serve as the advisor for this club since its inception. Every year, you do some seriously fantastic stuff. Not only kind of stretching the bounds of what people think young engineers are capable of, but this group provides a tremendous service to mechanical engineering, where I'm from, College of Engineering, and the entire university. So really, I got to thank you for that. And my job is to basically attempt to support y'all in everything that you do. Being the club that works with, planes, drones, and rockets, we often have to ask for permissions to do things. And this semester, I'm going to try and continue to help you out with all that good stuff, with either off-campus launch sites, things like that. And in terms of budgetary things, every project that you've done, I mean, you always deliver. So if anybody's got any dreams or ideas and things like that about what you'd like to do, please reach out, and I'll support you wherever I can, and also the department, things like that as well. I'm hoping that this semester I don't know to what extent they're going to return to a sense of normalcy, but I want to applaud everybody for your patience in basically how we go about our business. I know this is not really what you signed up for, but again, I really, really want to thank you all for finding creative ways to do things and for really staying the course. So I do want to say two things in that regard. One, if there's anything extra that we can do, I'm saying like Royal We or department can do to kind of help you out with your enterprises as you explore remote projects, ideas, things like that to build community, please, please, please reach out. Many of you have my text number. Feel free to share it or email. The other thing, I'm just going to kind of say this explicitly. Y'all are part of Northeastern University now. So it is really our job to think also about your overall well-being, your challenges, and I'm going to say it, your mental health, okay? We want you all to be as strong students as possible. So I'll say this, even if it's not Rocket Club, even if it's curricular stuff, department, university stuff, if anybody's got any questions or challenges, please, please, please reach out. That is the type of stuff we want to really keep tabs on. I'm so glad all of you are here and so glad you all are sticking around. You've got a fantastic leadership team, and the way they talk about you, they are just working tirelessly to provide projects for all of you to move forward with. I'll just say this because I'm not going to be here too long. Folks, I'm not sure how the lab situation is going. Let's make sure we can work that out. I'm going to be wicked available for that. Your TA, reach out. We'll have a meeting and figure that out. But I'm just going to be a fly on the wall, but really very, very glad everyone is here. And if anybody's got any questions or concerns, please feel free to reach out. Thank you so much.
Yeah, thank you.
Chat. Yeah.
Yeah, thank you so much, AG. As you said, we are very much indebted to AG for the lab space, for support on intro. We really do need it as a club, and so it's great to have both his backing and the backing of the College of Engineering, and people in risk services, Center for Student Involvement, everyone. So with that, I do want to just say that's all we had for our kickoff meeting. If you are interested, I know Ryan mentioned the Kickoff Connections channel in Discord. I would really, really encourage you all to go, put a message in that channel. Hey, here's what I'm interested. Reach out to project leads directly. I'm also happy to just stick around in this Zoom chat for the next 15, 20 minutes and answer any questions, point people in different directions. Yeah, that's all I had. Thank you all so much for coming. As I said, I'm optimistic about the semester. So let's go out and make it happen. So thanks, everyone.